Hello viewers, this is Mahesh from Mahith Academy. From today onwards, I am going to start all the electrical subjects, electrical circuits, electrical machines, power systems and power electronics. All the lectures corresponding to these lectures, I am going to solve all the previous years GATE, IES and AP transco, AP genco, tstransco, tsgenco, APPSC, tspsc question papers solutions. So please watch all the videos carefully and subscribe to my channel so that you will get all my videos and you can utilize all competitive examinations materials also. So let us start our session. So in this session we will discuss about the basics of electrical circuits and basic parameters and how to solve electrical circuits problems without any error. So while starting the topic, I have to introduce about some basic parameters. So while conducting the analysis of circuit or while solving any kind of electrical circuit, we may observe few terms basically. Those are resistance, inductance, capacitance. These are also called as basic parameters. And also we will observe few terms like voltages, currents and powers. So before starting the analysis of any circuit or before solving any electrical circuit, it is very important to understand these terms first of all. And later while solving the circuit, we must pay attention on plus and minus signs which is labeled to voltage sources. This is how we can observe in voltage sources how we will place plus and minus signs, and also the arrow direction given to current sources. So like this we can observe in current sources or currents the arrow how it is mentioned. So these two are the very important points to remember while solving any problem. Why? Because these two will gives the difference between right answers and wrong answers also. So one more thing is, we already discussed that the basic parameters that we can observe in electrical circuits while solving. So these basic parameters are also called as resistance, inductance and capacitance. Let us see, we will discuss about these basic parameters first of all. So first one is resistor. We know the definition of resistor. Resistor is the element at which it opposes the flow of electric current through it. So that is the basic property of any kind of resistor. So this resistor is represented by a symbol R, capital R, and the units for this resistor is ohms. And also we can define this resistance value in terms of Ohm's law as the resistance R is given by V by I using Ohm's law. So and again we can find the power absorbed by resistor, that is P equals to V into I, which is also can be written as I square R watts. And energy lost or energy dissipated in the resistor in the form of heat is expressed as W equals to integral of P into dt, which is also equals to Pt. Or else we can write I square RT, or else we can write V square by RT also. These are the equations for power and resistance equations of a basic parameter resistor. And next, coming to inductor. We know the inductance is the property of a material which also opposes the magnitude and direction of the current flowing through it. So the basic symbol of the inductor is also shown in the figure. So the basic symbol of the inductor is a wire wound and it is represented by a letter capital L. And also the units of this inductor will be Henrys according to Faraday's laws of electromagnetic induction principle. In inductance, when a current I is flowing through it, there may be a voltage V induced in it. That is how in inductor the voltages are induced. Next, coming to inductor properties, we have to observe the properties of inductors. If the current is constant means d by dt of constant is 0. So VL becomes 0. Inductor voltage becomes 0. So when we experience this current constant, we can experience in DC circuits. In DC circuits, the current is constant. So the voltage across inductor when inductor is applied to DC circuits is 0. That is short circuit we can represent. And also when a small change in the current in 0 time causes infinity voltage across the inductor. So this is the reason the current in inductor will not change suddenly. And the power absorbed by inductor is given by P equals to V into I equals to Li into di by dt. Also energy absorbed by the inductor equals to W equals to integral P dt, which is we can written as half Li square. So inductor stores the energy in the form of electromagnetic fields. So this is about inductance property. Next, coming to capacitance. So capacitance is the property of the element to store electric charge within it. A capacitor stores energy in the form of electric field being established by the two polarities of charges on the two electrodes. So capacitance is a measure of charge per unit voltage that can store. The unit of capacitance is farads, and Q being the charge that can be stored in a capacitor of capacitance C against potential difference of V. So we can write the capacitance equation C equals to Q by V. And we see from the fundamentals the current I equals to C into dV by dt of the capacitance. And also we can observe the power absorbed by capacitor is P equals to V into I. This can be written as CV dV by dt. Energy stored by capacitor can be written as W equals to integral P into dt. From this we can get half CV square. While we observe the properties of capacitor, the voltage across the capacitor is constant, so that the current through it is 0, which means in DC circuits the capacitor acts as open circuit. A capacitor never dissipates energy and it will stores, and a small change in voltage causes infinity change in current also. So this is the reason a capacitor never allows sudden changes of voltage across it. So these are some of the resistors of different ratings that we can observe practically while constructing any circuit. Look at this, these are the practical resistors we place in the electrical circuits of different ratings. And next, these are practical inductor that we can define this inductor as the number of turns wound on a toroid or a iron piece that can be represented as a inductor. This is a practical inductors, and these are the different ratings that we can see for different purpose practical inductors. And these are also some of the practical inductors examples. And next is the practical capacitances. These are the different capacitors with ratings for polarized and non-polarized capacitors available. 470, 300 volts, 200 volts, like this different voltage ratings. These are the capacitors, and these kind of capacitors we can observe mainly in household appliances like induction machines, fans and refrigerators like this. These are the capacitors that we can utilize in industrial purpose also.